And I think it's on.
Okay, well, this is going to be an overview of NASA's crowdsourcing, or what we call Open Innovation Toolkit, that I want to go over here today. And let's just dive straight in. Just to give you a little bit of a feel for who we are just before we get into this. We are NASA's Center of Excellence for Collaborative Innovation, and we actually work across not just NASA and all of the NASA centers and programs, but also across the entire federal government. And we help organizations to try to understand and use open innovation tools, and I'll talk more about all of that. As you might know, NASA, we have lots of really substantial challenges. There's a reason we're not all living on another planet right now, and it's because it's really hard and really expensive. And our job at NASA is to reduce that risk and eventually bring in the commercial world to pick that up and to work with them to actually get farther and farther into space. But we have all of these big technology challenges ahead of us. And when it comes to innovation, it turns out innovation is this kind of interesting formula where it's innovation is really only valuable in its realization. It only actually works for you when it pays off, right? And it just in theory doesn't really help you much. And so we talk a little bit about how innovation is kind of 1% inspiration and 99% perspiration, where 99% of the time your energy is going into making this a reality. And that 1%, that idea, that starting point, that set of technologies you use is actually just this tiny little sliver, but it kind of works like a math equation. Not only does it add up to 100%, but that 1% turns out to be this really important multiplier on the effectiveness of whatever you are working. And so if you have a really great innovation, a really great set of technologies and ideas that you're working from, then that can be a 10x, a 15x, a 100x improvement in performance over where you currently are, which is mostly when we talk about problems, we're really trying to improve something, right? And so if you take the low hanging fruit of what's available when you go to try to solve a problem or try to improve a system, you can actually just end up with kind of an incremental improvements rather than these very transformational. And so it's really important to put the right work into that 1%. In that discovery. In the engineering world, we talk about the funnel, right, where you start in that discovery mode, looking for those ideas, those technologies that you're going to base your design on to move you forward. And in the years that I've worked at NASA, I've worked at NASA for over 30 years, you would talk to some vendors, some experienced engineers, go to a few conferences, and you would be able to figure out, okay, these are the right chipsets to use, these are the right antennas, this is the cutting edge. And sometimes you would even put some money into the maturation of that cutting edge to get it to where you could then use it in your design. And then you would spend literally years and millions of dollars trying to actually get that into flight. And that was kind of the model that we had. Not a whole lot of money in the discovery phase. And by the time you delivered, you not only based it on a cutting edge technology 3 years prior, but it would still be the cutting edge, and you could do that with high confidence. But that's not the world we live in now. Things have changed significantly. I really don't have to tell most people this because they see it around them. But what I tell our workforce is it's bigger than you think. The change around us is actually starting to break some of the very kind of foundational processes and structures within the workplace. And so the things that worked for us for literally 100 years are starting to become ineffective. And a lot of that is, if you look, even something like the world's population, it has doubled in the past 50 years. In my lifetime, and I'm a little over 50, it has literally doubled. And keep in mind, if you start in the Common Era, it took 1,400 years for the first doubling. And now we're in a phase of that curve where it's doubled. And the impacts of that are huge, because not only has the population gone up, but the countries around the world have gotten more wealthy and they've started to educate more. And we're now seeing the results of that, where secondary education has increased by over 2.5 times in just the past 20 years. And we're starting to get more and more people out there in the technical workforce. And the results are that if you were to add up all the scientists that were alive today, or no, for the entire span of the Earth, 90% of those scientists that have ever lived are alive and working today. So there's this just huge amount of technology and work going on. And while we understand that there's a lot of tech coming our way, I don't think we fully appreciate how big that tidal wave of technology is. And if you look at patents, they've gone from just a few 100,000 a year, spiking up to over 3 million just in 2017. And in fact, that has really kind of broken some of that system. Now it takes a really long time to get all those patents approved. You look at the PhD programs, they've spiked and we're getting a lot of folks. You can look at funding for research, it's spiked all the way around. We're getting a lot of technology work going on. And I like to talk about some of the things that are really interesting about that. And that is, in this accelerating rate of change, we're seeing building blocks emerge that are actually speeding things up even more, right? These are low cost and typically easy to learn for a lot of people, very accessible technologies like open software APIs, machine learning, blockchain, CRISPR, 3D printing or additive manufacturing, robotics, complex manufacturing, really cheap sensors. And all of these not only are just accessible, but more importantly, they apply and are used by almost every industry out in the world. So they're not just for aerospace, they're not just for medicine. And in fact, if you were to plot them across kind of a plot, you would see that not only is there, you would see that you have lots of domains here. We're one sliver, and if you kind of measure the depth is complexity going up, then if you were to plot folks doing, say, AI or machine learning work, you would see that almost every industry has some development work going on in AI. Some are way ahead and some are falling behind. And you know, maybe we at NASA, we have lots of work going on in that area. The thing that we miss is, because everyone is innovating with these new technologies and combining them with their own technologies and with other things, that there are actually opportunities that come back to our industry based on what's happening in other industries. In other words, they're developing solutions that could be used for us. But let's just say that that's John Deere working agriculture over on the right there. It could apply to what we're doing, but if we were to sit in on that presentation, we would not be able to detect that it's something we could use. We don't understand their lingo, we don't understand their problems, and translating and connecting the dots is really hard across these domains. So we have this kind of pro-con situation where the pro is that we've never had so many latent, amazing technologies and solutions that could help us find and implement 10x, 100x improvements. But the con is you can't find them. In fact, if you think you can Google the latest and greatest technologies, then you simply don't understand how big this technology explosion is and how these technologies are hitting the market and where they're hitting in these various domains. And so this funnel, right, working has now changed. Now you have many, many, many more technology options at play, many of which are hidden. And if you don't pick the right ones, if you only pick what you're familiar with and what worked last time and what you see in the news as cutting edge, then it's very possible that you'll spend a couple of years and several $1 million implementing a system that you'll wake up one day and you will find in the news someone has actually created a technology that outperforms that, not by a little, but by a lot. And then you've got to go to the program manager and say, hey, there's new technology out there. We need to decide, are we going to throw away all of our investments we've made to date and switch to this new technology? Or are we simply going to use what we've got and have poor performance, which then has additional impacts through the life of your program? And you never want to have to go to a manager with that, right? And this isn't, we're not alone in this. This is happening everywhere, where the rate of the technology, not the technology itself, it's the rate at which it's coming at us is really increasing to an unmanageable speed. So it's not only hard to keep up with these tech advances, it's hard to actually find people with the expertise and skills necessary to even understand these new technology advances, much less take advantage of them. And so for organizations like NASA, and I can tell you, I've been in many meetings with upper management, they see there is a high risk that we remain competitive and relevant. And this is not just NASA, but everyone. Like, you look across the US's most successful companies, and over half of them over the last 15 years have actually gone away. The average lifespan of companies has shrunk from almost 100 years in the early 1900s down to less than 18. And so this isn't just a new problem, it's been coming at us, but it's reaching kind of a critical mass. I like to just show an example of kind of how this kind of surprise disruption works. Subsea 7 actually does pipeline inspection for undersea pipelines, and they take a ship out at $1 million a day, and they lower a van-sized piece of equipment next to that pipeline, and then they take about 2 weeks to inspect the pipeline. And they went out to 9 Sigma, which I'll talk a little bit about these platforms, but within 2 weeks, they found a new technology. It wasn't actually a new technology, it was a technology already in use in the mining industry that could do that same job in 2 hours instead of 2 weeks, and was handheld. So not only is this 100x faster and more effective and less expensive, but what they said, the bigger impact for them was they realized if they had not found this technology and their competitor had, they would no longer be in this business. And that's what we're seeing over and over, is disruption where technology matures in one industry, pops over to another, and causes huge disruption. So if you're an organization and you are trying to innovate, you're trying to keep on top of this, normally you hire within your domain, right? It's kind of pretty common. You hire aerospace folks if you're in aerospace. And if you're searching for these innovations that are latently out there, and you're trying to find them and trying to find both the ideas and the technology and put them together, if you put an individual on that, yes, they'll be able to innovate, especially if they have good innovation training. There's really good programs around that, but they'll still only be able to access kind of what's in their domain and in their vocabulary, right? If you put a team on that, you're going to get better performance. You always get better performance out of a team. But here's the thing, at the very time that you've got this really hard search problem, it turns out that there's something new, and that's the crowd. And the crowd actually works as a dragnet. And just statistically, you end up with people in every domain that allow you to kind of sweep across all the domains to find these ideas and technologies and innovations that really you can't get to any other way. And so that's what I want to talk a little bit about today, is open innovation. So open innovation means, basically, open means going outside of your group. So you can actually have open innovation where you're simply expanding from your small team to your larger organization, right? Or go all the way out to your entire company, or maybe out to the entire world. In fact, that's a lot of what we do. And this ends up being this really interesting model that has emerged over the past 20 years. And I liken it to a platform that provides you low friction matching at scale with high trust, right? So you can think of it kind of like Uber and Airbnb, right? Uber is a platform that allows you to very quickly and easily match people who have a car and can give you a ride with someone who needs a ride, right? A couple of clicks on the button. And I like to remind people, when it first came out, everyone said, hey, there's no way I'm getting in a stranger's car. And in a very short amount of time, they were able to build trust with the consumer. Now almost everyone does. Same with Airbnb, right? You're matching people who have a space in their home with people who actually need a place. And now that's happening with innovation with these new platforms. And some of the same techniques actually are still being used. When we talk about platforms, we talk about these communities, we talk about open innovation communities, we're talking about curated communities largely. Now you can go direct to the public, but what we found is that that the real phenomena and the real success is happening in curated communities. So these are companies who have stood up a website, and they kind of have two sides to their network. One is crowd facing, where they actually draw in people from the public to join their communities, and they do that so they can connect with other people with that same passion, that they can learn new skills, that they can try out their skills, and actually sometimes even make some money. On the customer facing side, these companies have figured out how to utilize those crowds in kind of a win-win, where they can take those skills and turn them into actual solutions for organizations like NASA. And these are like Topcoder, right? 1.5 million software developers and data scientists who, really run the gamut of skills in a very competitive field. But they're on there because they love software, and they do contests, and they have an entire process for how to generate and build and maintain code. But they're there because they are passionate about it, right? GrabCAD, passionate folks around computer-aided design, mechanical engineers design and designers, almost 9 million of them. Agorize, HeroX, Incentive, Nine Sigma. These are all communities built around problem solving. These are those folks that remember all the math from college, and they are the folks that really like to do puzzles in the paper every week and things like that. And they gather in these communities to solve hard technical problems. And some of these are really huge. I think Freelancer's almost up to 55 million users in one community. So lots of interesting things happening. And the model works something like this. If you think statistically on any expertise, right, or skill, you're really looking at a curve that looks like this blue curve, right, where you got general secondary education at the mean there, but then you've got way out to the right the world's experts, right? And if you're like NASA, you actually hire really well, right? You hire some of the smartest people in the world, and we hire some of the smartest folks. We start at a very high level, and we have some of the world's experts. But what I tell our workforce is, yes, but we are really this very tiny blip when it comes to how many people are out there, even in space-related things. These days, there are a lot of people out there. Some have been through our industry. Others are in the commercial side of things. Some folks are at universities. It's really everyone. And the opportunity for us, if expertise is what's going to solve your problem, is accessing those high value, high expertise folks on the right side of that long tail, right? And in fact, we find these curated communities have some of these people. Because think about it, Topcoder, if you're a software person and you're taking your free time and joining a community around software and data science, you're already on the right side of this. You might start a little bit, but you're motivated and passionate about learning more. And we actually find some very highly skilled folks out there in these communities. But sometimes it's actually, we're looking across lots of domains. So like, it's not one expertise or one skill. And if we look across, we find that if we look across domains, that yes, in fact, we can find solutions in those domains. And a lot of times those people don't have to be the world's experts. Sometimes they're just someone who knows enough about both domains that they can connect the dots and are able to find a solution for us. And in fact, that's what the data shows. MIT did a study of Incentive, one of these platforms, their successes. And what they found was, of all those successes for solving hard problems for companies, 70% of the time, the challenge was actually solved by someone who was not in the domain of the challenge. In other words, if the challenge owner was a chemist and bringing a chemistry problem, most of the time, 70% of the time, it was not a chemist who solved the problem, because chemists tend to all kind of have the same thought process, and a lot of those they've already tried. And so it's these other domains that end up solving. Now, they may have some chemistry background, but it's someone who's actually over here in another domain, again, connecting the dots. And 75% of the time, the solver already knew the solution. In other words, it already existed, which again goes back to that kind of latent solution idea. And this is what we're seeing. We're seeing lots of solutions, which is nice that they're already existing, because it also means they're more mature and quicker to implement. Okay, but how, right? I mean, just because you can access 50 million people doesn't mean that that's going to make it easy, right? There's a huge signal to noise ratio problem where you basically are trying to figure out how do you get and filter those down to something that's really useful. And it turns out the what I call the magic matching algorithm for innovation right now is challenges, is prize-based challenges, but it's not just prize-based challenges. It's that these platforms know how to formulate the problem statement, design the challenge, how many prizes, how much should the prize be, how is it structured, are there multiple phases, how to execute the challenge. They deal with the public, they answer the help desk. Trust me, you don't want to deal directly with the public. It's a lot of noise in that that you don't want to have to deal with. And a lot of these platforms have kind of trained their membership on how to do this stuff so that there's not that barrier of entry of, I don't know what to click on, right? Solution filtering, all of our contracts that we do with these curated crowds, we actually have requirements that, hey, you're only going to provide to us for evaluation those solutions that meet certain criteria and that meet our requirements. And so we don't have to look at all the crazy kind of non-functional type of solutions. And then lastly, they help us with our licensing and IP, because this is something where you have to protect the challenger or the challenge owner, as well as protecting the folks that are participating on the challenge. And you want to make sure that at the end of the day, everything is fair, documented, and that you have the right rights to your solutions. I'd like to provide just a couple of real world examples, and then we'll dive in and I'll show you some NASA examples as well. But one that's talked about a lot, at least by me, is a company that came into an incentive, and they wanted to remove grease from their potato chips, whereas I took this to Europe, so I called them crisps, right? And the way they were doing that was to mechanically vibrate the chips so that the oil kind of came off of the chips as they came out of the oil, as it shook the chips, but it would also break a bunch of the chips. And we as humans, as you know, only like the really big chips, right? The big ones, whole ones. And so the first thing that Incentive did was they changed the problem statement to how do you remove grease from potato chips to how do you remove a viscous fluid from a delicate wafer. And this did two things, right? One, it obscured the chip maker so that no one knew this was a potato chip or a food company, right? But the second thing was more important, and that was that it broadened it so that it wasn't just an attractive problem for food production engineers and food scientists, but actually anyone who understood viscosity of fluid and delicate wafers, and that could be really a whole range of folks and domains. And in fact, they ran this challenge, and within the 60-day challenge, they actually found a solution, which was to acoustically vibrate the air around the chips at a resonant frequency that caused the cooking oil to separate from the chips and left the chips intact, right? And what I like to point out is food production engineers are largely mechanical engineers, and I'm a mechanical engineer, and our expertise is vibration. And in fact, you could see the solution that was existing was to vibrate the chips as they came out of the oil. But that entire set of mechanical engineers, even though they were experts in vibration, remained blind to this solution. And this solution actually came from a violinist, who I would argue is also a vibration expert in a very different domain. And she had seen the rosin fly of her bow, understood resonant frequencies, and basically submitted that as her submission. And this is the power of the crowd. It's that different expertise, that connecting of the dots, that kind of breaking through that shell that experts often have from seeing obvious solutions or solutions that can work. Roche Diagnostics, they're a multi-billion-dollar pharmaceutical company who basically brought some of their hard problems that had been unsolved to Incentive to see if they were really trying out open innovation. And they brought one problem they had been working on for 15 years, and that was it was an in vitro diagnostic machine, and they needed a very precise measurement of the intake samples quantity and quality, and they had not been able to achieve that, so they couldn't bring this to market. So 15 years of trying different consultants, bringing folks in, and they went to Incentive and they basically ran a 60-day challenge. And not only did they solve it, but again, the solution independently came from two different solvers, which meant it existed already, they just didn't know about it. But what really kind of blew their mind was that Roche looked at all of the submissions and noted that everything that they had tried with their experts in 15 years of proprietary research had been replicated in 60 days. And we often talk about innovation and failure, and how important failure is to innovation. I would pose that one of the values of open innovation is massive ability to fail rapidly and be able to find those working solutions that rise to the top. So it's really interesting stuff. And in fact, this is kind of shown when you look at data science. So data science, Harvard was really trying to figure out, was this simply finding that one person that was really good at this, or was this actually doing something a little bit different with algorithm challenges and data science challenges, because they were getting such amazing results. And so they partnered with National Institutes of Health on their MegaBlast algorithm, which was kind of their workhorse for doing this kind of nucleotide sequence alignment work. And it ran on their standard machines in about 4.3 hours per machine, and its accuracy was 0.72. Harvard went out and hired some folks that were both domain specialists in this kind of work, as well as top-notch data scientists. And they paid them $120,000, and over a year, they improved that algorithm significantly in an order of magnitude. Got that run time down to 47 minutes. So now instead of a couple of runs per day, you could do maybe 10, and simultaneously increase the accuracy. So really a great solution here. They then ran a 2-week marathon match on Topcoder, one of these open innovation sites. And within 2 weeks, they, offering a $6,000 prize, right? They had a solution that ran in 16 seconds and had a higher accuracy at 0.8. This chart is logarithmically getting faster as you go right to left and getting more accurate as you go up. And you can see the big red dot is the winner. But what's fascinating, again, where you're looking for just one person, well, guess what? Those 25 little red dots to the right, those are all the losers who all had solutions 2 to 3 orders of magnitude better than the baseline, and 1 to 2 orders of magnitude better than the grad students, right? So this is the kind of thing we're seeing, and in fact, you can see a ton of different approaches were identified there, which means you can actually go do more. And this is what we're seeing in data science, that we're getting really amazing results out of the contest model, and that community really likes that format and participates a lot. Okay, so those are some examples. I'm going to return back and talk a little bit about who we are. So as a Center of Excellence, we, again, not only work across all the NASA centers, but we actually work across the entire federal government, helping organizations and projects and programs to use these tools. Now, our brand, our public brand, is called the NASA Tournament Lab, and that's kind of where that term comes in. And the way we do this is really, we try to break down the barriers of entry of using these new tools. So that means we already have the contracts in place, so you don't have to go through contracting. We already have processes and understand the legal and understand the procurement pieces, so that you don't have to do that. So with that process, and then we call it the Sherpa process. We actually will have someone that works with these programs to take them through the process so they don't have to get lost. Because a lot of times, anytime you're doing something new, you hit that first barrier and you're like, this isn't worth it, right? We do a lot of outreach and education, as well as research with various organizations like Laboratory for Innovation Science at Harvard, MIT, and others. We are actually part of the Space Technology Mission Directorate, part of their Prizes and Challenges and Crowdsourcing program, and we have the core of our team located at Johnson Space Center in Houston. However, we are actually part of this Prizes, Challenges, and Crowdsourcing group, and a bunch of crowdsourcing work at NASA. And so within our Center of Excellence, we cover the NASA at Work, which is our internal crowd, our crowd of employees, of about 30,000 employees, both civil servant and contractors at NASA. We have the NASA Tournament Lab, which I'll talk more about. But then we also, our sister program is the NASA Centennial Challenges program, which has been around for really the longest of all of our crowd work, and does really large scale kind of big stake in the ground challenges, kind of like you would see with X Prize or DARPA Self-Driving Car Challenge, that kind of, and they do multi-million-dollar prizes over multiple years to kind of drive industries to form around new technologies. International Space Apps is the world's largest hackathon, happens once a year, just happened, I believe, here in October. Citizen Science, there's a bunch of different citizen science projects out there on sites like Zooniverse and others. Student challenges, there's a whole host of student challenges. In fact, when a lot of people hear about challenges, that's actually what they immediately think is student challenges. But we actually have a lot of really significant work challenges as well as these student challenges. You can actually find all of this work on our nasa.gov/solve site where we list all of those. This is our team as it stands today, but we are actually expanding and changing as we speak. And so you can see it's a very small team of about 10. Amy Kaminsky at headquarters kind of leads that prizes, challenges, and crowdsourcing program. But it's a really dedicated and high-performing team that we are building and growing. And we don't just work with NASA and other federal agencies, but we actually collaborate because this is a new toolkit that the entire world is starting to embrace and understand. We've kind of emerged as one of the world's leaders in this. And so we talk to universities and companies and governments about what we're doing, and in some cases we're learning from them because other folks are using these toolkits for different work, and we're learning a lot as we go, and we're kind of a hub of learning because as a government agency we can talk about this in ways that private industry simply won't for competitive reasons. So really interesting. We've worked with over 80 organizations around the world, and we'll continue to. Now I keep talking about the toolkit. So what is that? So our toolkit is really a set of contracts is the way we like to think of it. In fact, we've got our Noise 2 NASA Open Innovation Services 2 contract, which is our largest multi-vendor IDIQ contract, indefinite quantity, indefinite deliverables. I think I said that backwards, but it is this contract with multiple vendors on it that allows us to actually do a whole host of different types of work, and I'll talk more about that. We have a contract with Yet2, which is a technology search company, with Future Engineers as our kind of platform for education challenges. Over on the right, you can see we have a contract with IdeaScale, which is our platform for our internal community. And then we have agreements with like as I say, Harvard and other universities to do research. And then we've actually learned how to use a purchase card, a government purchase card for things under $10,000 where we can actually run challenges and get work done. And I'll talk a little bit about each of those. This is our biggest, I'm sorry, this is our entire, what I call our Logo Fest page, which shows kind of how all of those companies and curated crowds interact with us in various ways, but it totals something like 40 different communities that we have access to that represent, I think it's at last count about 120 million people worldwide, and that is really flexible in letting us figure out how we want to work. One of our best and kind of the crown jewel of our open innovation work is our internal crowd, because we do have amazingly innovative folks at NASA. So we call that NASA at Work. That is our internal crowd. You can kind of see the platform here, and we basically run challenges internal to the program, so and internal to the agency, so that we can really do enterprise knowledge sharing. So we can say, hey, look, we're trying to solve this problem. Does anyone at the agency know how to solve this problem? And a lot of times those folks either have worked in that area, or sometimes they will actually know of work outside of the agency even. So they actually work as this network that we can really get into. So really an amazing program that we have, and we will continue to build. Again, most of our challenges that we run on that are successful. We run over 200, I think closer to 250 by this point. Lots of cost savings there. Interestingly enough, we don't offer monetary awards in there. We offer things like cool NASA experiences and management recognition. It has the prize for that, and it is this really kind of low cost of entry way to go do challenges, because we don't actually charge the projects any money to go run these, and it's become this kind of hub of innovation within the agency, where people come to interact with various programs for program calls, for conversations about emerging technologies and challenges. Just an example of kind of what we've seen from that, we actually had one of our folks from Human Health and Performance who was trying to get a better way to measure urine volume in microgravity. I actually used to work on the urine volume in microgravity system. There's this huge box that would spin the urine. Anyway, one of my more interesting projects. But they're trying to find a more reliable, smaller profile, more accurate way to do this. And so he came to NASA at Work before he went to go do, SBIRs and other kind of development programs, just to see, does someone else have something out there? And sure enough, after running this challenge, he actually found in a lab literally 300 yards away in the next building over in Building 7, that there were folks who had a working prototype that actually would work for what he was trying to do, and it ended up saving him, well over $1 million in several years worth of development and effort. So this is the kind of thing we see there. You can also see using thorium instead of uranium. We were trying to explore that, and it ends up, as Michael was trying to figure out how can, what is it that we know about this alternate to uranium, using a NASA at Work challenge, he found that not only had NASA already funded research at a university that he didn't know about, but also there was a guy who was about to retire from NASA who actually pulled from his files Apollo era research that really would be really expensive to replicate. And so, again, that enterprise knowledge sharing aspect. One other here was trying to work on the radiation protection. Dr. Pugel was basically trying to find better ways to do this, ran a NASA Work Challenge, and found again this history that someone actually had proposed a solution in 1967 that at the time couldn't be manufactured, but now with technology advances could be, and started to show promise in this new area. So if you're interested in that and you're working at NASA, I encourage you to go to nasa.nasa.gov and sign up, because all you need is your NASA ID for your Launchpad login. I want to go through a few of the kinds of challenges that we do on our external sites, and some of these we do internally as well. But a lot of people think of these innovation and problem-solving challenges, where you just have a problem. How do I solve this problem? How do I get better performance? And these are some of the companies that specialize in that. One was how do we measure intracranial pressure non-invasively so that we could actually work out the sight problems that astronauts were having? And the only way to do that really was spinal tap, which is really invasive. And so there were Jennifer Villarreal, who was leading that team, was looking at that, and we ended up running both an incentive challenge and a yet to technology search for that. And really, she had thought she knew exactly where she was going in her research, and after running these challenges, discovered entire new veins of research and really pivoted her entire R&D efforts based on the results that came out of that, and then came back and ran another after a few years to kind of update that and really steered that research in a much more positive way. The Mars Balance Challenge, this is where, in that 7 minutes of terror that you hear about a lot, as you're going from space into a very thin atmosphere, the aero surfaces don't quite work yet, and the thrusters don't work either, because you're coming out of space, out of vacuum. And so they would actually eject these masses, almost like balloons do, to navigate. And so just as you're coming through, they eject mass, right? And if you're going all the way to Mars, you realize mass is the one thing that's really expensive to take all the way to Mars. And so there was always this feel that, wow, wouldn't it be much better if we're going to send all this mass to be used for this at Mars, that we can at least get some scientific return out of it? And so we basically ran this incentive challenge and really found from it was a pipeline engineer from Rising Star, Texas, this teeny tiny town, who submitted an idea that says, look, if you make this ballast out of barium, when you eject it, it will dissolve in the atmosphere, and you can use your orbiting mass spectrometers to actually detect what's the composition and characteristics of the atmosphere. And he actually went and briefed the the JPL team on this was really fascinating. So pivoting to technology, sometimes we simply want to know what's out there that we can go buy, right? We don't even need it to be this kind of lower TRL discovery. And we found there's a company called Yet2 that has done an excellent job for us, and it's kind of our workhorse. And you see, just in a series of searches we did for lunar dust, we found that these are the experts that know all about lunar dust and all of the vendors who are out there. And after we did this technology search, we found that there were at least 25 different vendors that actually had technologies that our team was not aware of. So again, those changes are happening fast, and how do you detect those? Data science, again, we have several vendors who are really experts at this and do a really great job at it. One was Topcoder, and they actually helped Victoria Friedenson from headquarters, who was really trying to improve the Catalina Sky Survey and the ability to detect asteroids. We used Topcoder again. Not only did we end up with an improved algorithm by about 15%, so you're taking a series of images and actually trying to find a very dark asteroid in them before it's too late, improved that algorithm, but also for less than $200,000, packaged that up into a downloadable multi-platform app that amateur astronomers could use. So then we actually were able to crowdsource the detection itself, so we get lots more eyes in the skies looking for asteroids and trying to protect the planet. Like I said, we do work with other federal agencies. Homeland Security came to us and said, hey, we are trying to improve our next generation millimeter wave scanners that are used in airports. Can we work with you guys to kind of come up with a better algorithm for that with this new technology? And so we ran a Competes Act, which is kind of one of these acts that allows for direct funding of prizes. And we ended up running a $1.5 million prize. The whole challenge ran at about $2.5 million. Ran this with Kaggle, who's now owned by Google, and ended up with 8 different algorithms that really had amazing performance. One with a 98% detection rate, which was significantly higher than anything they'd had. And you know, they were like, this is the best $2.5 million the DHS has spent in a very long time. So getting really good results like this is kind of the core. Kind of a surprise to this coming into this was that people can actually develop software and do kind of complex development work using challenges. Topcoder is kind of the pro at this, they're the model, and they have taken that software development lifecycle that most folks are familiar with, and they basically atomized it so that each of those steps becomes a challenge, and they actually run them in this kind of sequence so that you get kind of the best of the folks that are the best at that. So the folks that are best at user interface and generating wireframes, the folks that are best at architecture, working architecture. And it kind of gets that subset of their 1.5 million crowd getting the best of the best to work and work on this. So it's a really interesting model. We've actually developed and flown flight software that's developed using this. This is where the head nutritionist here at NASA needed a better way to develop or track the crew nutrition. We actually ran a NASA at Work challenge first to find ideas on how we could better collect, and one of those was an iPad app was the idea. We took that to Topcoder, they developed it, and really for not a lot of money, we were able to build an app. And it was interesting, the crew's comment on this was, wow, this must have been developed outside of NASA because it's so user-friendly, it's so much like a commercial app. And in fact, this won an award at the Apple Developer Conference, so it was really interesting. Kind of a challenge, and you can kind of see here, there were actually 21 challenges within that one project where, you know, 55 different folks worked from around the world to actually build that software. Emily Law from JPL actually was working on trying to reduce the processing time for stitching together at the LRO images, the Lunar Reconnaissance Orbiter images. And so we used Topcoder, and they were actually able to re-architect that software so that it could work across multiple nodes at one time and basically provide a 6x improvement in that processing time. So down from 19 hours down to 3 hours. Okay, shifting to our P cards, right? So I said we could use a government credit card to go run challenges. It's really fascinating. We're trying to figure out what the limits to this are. We've run over 50 projects now, including software and CAD, graphics, video. We've run a whole series of small graphics challenges. What's really fascinating here is we're engaging the public to help do something that really isn't space stuff, right? I mean, it's graphics work. But what we find is we get emails from people that say, thank you for letting us be part of NASA, being part of the mission. And it kind of came as a side benefit, but what we realized is for years, NASA's been basically putting itself out to the public as, look at the cool stuff we do, don't you wish you were us? And these challenges are providing people an opportunity to be part of us, to work as part of our NASA team. And we get just repeatedly folks that is what motivates them to come and work on these challenges. CAD work, we've done a whole series of computer-aided design work and finding some amazing folks out there, amazing talent. We actually ran a series of Astrobee robotic arm architecture challenges where I think we had something like 17 challenges that ranged anywhere from $250 up to $5,000, and each one was getting these amazing robotic component designs. And when we put all of those designs together, and George Washington University kind of was doing this as research, and they analyzed those, they found that 8 of the 9 composite designs were actually outperforming the actual real design that we use on Astrobee on space station. So some amazing work we were getting out of folks around the world. Had some folks who were trying to prototype a smartwatch app that the crew could use, and basically we used Freelancer to design that and code it, which there was a little bit of a surprise. We'd spent about $1,500 getting the user interface design. It was this really great design, and Freelancer basically came back and said, you know, we can find somebody that will code that for you for less than the credit card limit. And we were kind of taken aback, and sure enough, turns out working for NASA has a lot of value to it, and a lot of people want to be able to say, hey, I did this for NASA. And so it's really kind of an interesting area. The Realm project works RFID on space station. They did a small challenge to come up with a video. Again, for about $4,500, we ended up with this really high resolution, full CGI 3-minute video explaining their project, something we never could have afforded using our traditional models. Okay, let me put a cap on the open innovation stuff. We've done close to 600 projects over the last 10 years and used a host of different crowds to do that. Most of those are successful. Where we have cost data, we find that about 3/4 have cost savings, and that cost savings is significant, right? It's actually something like 45% average. And that's not the case every time, right? Sometimes you're getting better performance and you're willing to pay for that. But we've spent about $50 million and we've saved about $50 million. So we've done about $100 million worth of work for half the price. The other thing, and I won't spend too much time on this, that we found after a few years of working on this is that some of our challenge platforms were also supplying freelancers and gig workers. And we kind of started digging into that and found that there's really some commonalities to these platform models that gets to be really interesting. We talked about how there are these, low friction matching at scale platforms. Well, it turns out that not only are they matching kind of shared resources like cars and homes and rooms, but also people like laborers at TopTal and Freelancer and Upwork and Maven were being matched to tasks at various projects around the world. And there's a study by Edelman Intelligence that was done back in 2017, and it was showing that people were moving into the freelance workforce at 3 times the rate of our normal workforce. And what's fascinating there is in 2019, there's a study that showed that over 40% of the average organization's workforce was non-full-time, and that's doubled over almost 7 years. The Edelman Intelligence study showed that by 2027, there would be more freelance workers than full-time workers. And that's a huge shift for organizations trying to hire. But COVID came along and it just accelerated all of this. And in fact, there was just about 2 weeks ago, MBO Partners came out with a State of Independence in America, which showed that between 20 and 21, just this last year, that freelance work has actually gone up 34%. And you're already seeing the shift, and you're hearing it in the news of folks having a hard time hiring full-time employees. That Edelman Intelligence, by the way, when they studied freelancers, they asked them the question, how much money would it take you to come back and work for a full-time employer? And a full 50% said that there was no amount of money that they would take to go back to work for a company full-time. And I think we're seeing that. Part of that is the lifelong learning problem in education. A lot of companies, their average spend on education is $1,000 per employee per year. And that simply isn't letting people upskill at the speed they need. And people are realizing once their skills become obsolete, companies drop them, right? They lay them off. And so a lot of people are starting to see this. And what we're seeing in the studies is that freelancers upskill at a much higher rate than full-time employees. In fact, I was on a panel with one of the top freelancers at Topcoder, and I asked him, how much time do you spend kind of learning new things? He said 60% of his time. I said, how do you make any money with only working 40% of your time? He goes, no, I make 5 to 6 times what anyone else in my country makes. So there's really some interesting stuff going on. Another study, World Economic Forum, showing that after COVID, more companies are scaling their remote work, accelerating their digitization, accelerating the automation, and that those things are having significant effects on jobs, showing 85 million jobs going away. 97 million jobs were coming, though. But these are all jobs that people have to upskill for. In fact, they were showing 50% of folks just in the next 4 years are going to have to upskill, and the amount of upskilling is something like 40% of their core skills. And so those skills require anywhere from 1 to 5 months of training. If you think about that $1,000 per year employee, no one is resourced to upskill at this level. And so this reliance on changing skills are coming. So a couple of years ago, we actually expanded our contract, our Noise2 contract, to include freelance platforms. So we have some of these listed here where we can actually go find experts and pull them in for a period to actually help augment our skills and workforce. I won't say much more about this other than this new workforce is on demand and persistent. In other words, you can use them as one-off, but you can also form relationships. In fact, a lot of organizations are doing that so that they are kind of creating this virtual ecosystem of workers. They're available both globally and locally. People think of these as only remote behind a computer, but the reality is people will show up in physical locations. The range of skills goes all the way from data labeling, which is almost no skill, all the way up to experienced, high-performing world experts. Again, the lifelong learners, these platforms are getting better and better at providing these folks quickly and reliably at high trust. So it's a really interesting area. So this is my get off stage, which is open really is the future. And innovation is no longer optional. Organizations have to do this. And for us at NASA, if we're serious about these giant steps, we have to learn to use these tools so that our solutions actually are these disruptors. We actually do have a challenge worksheet that if you're a project, you can actually go and start to understand what it's going to take to do this project. We'll work with you on that. We have a process we go through with you on that. And with that, I'm pretty much done. Thanks for listening.